in bedside monitoring. It's going to be a panel. I'm going to introduce Adam Al-Qaeda, who will be the moderator of the panel, and we'll introduce the speakers. Welcome, Adam.
Are we on? Are we on? Fantastic. Well, I'm really excited for this panel. We have a great group of individuals that will be joining us for a conversation. I know the conversation is titled as AI and bedside monitoring, but I'm excitedly confident that it will take many tangents that are very relevant to everybody's interests in this field, wherever your perspectives are. So, starting off with our first panelist, I'd like to introduce Dr. Josh McCower. He is the Yock Family Professor of Medicine and Bioengineering at Stanford University, the director of the Stanford Byers Center for Biodesign. He and Dr. Paul Yock founded the organization 20 years ago with dense experience in incubation and venture and a background in both medicine as an MD, MBA from a business standpoint, and also mechanical engineering. I welcome Josh McCower to the stage. Our next panelist is Dr. Chirag Patel, who is a McNair Scholar and Assistant Professor in the Department of Neuro-Oncology at the University of Texas MD Anderson Cancer Center. Dr. Patel focuses his time on research and education in the neuro-oncology space, and we are privileged to have him join us on stage. Last but not least, Gretchen Brown, which we did an introduction for. Please give a round of applause for her. Thank you. Of course. All right, so I'm really excited about this panel because we have perspective from so many dimensions of our industry and different sectors of the market and areas of interest, so this should be quite interesting. Both today at this conference, for the last 2 days actually, as well as worldwide, AI has been a very broadly discussed topic for the here and now as far as the developments and the advancements, all of the taglines and marketing that we've heard. But I wanted to start off our discussion more so pulling back and looking at the last 25 years of the digital enablement and transformation that's taken place in healthcare and life sciences. And would love to hear from your guys' perspective. Are there any foundational principles or things that we've learned, both from a product perspective, from a medical perspective, and a clinical perspective, that as we go into the data-enabled AI automation era of healthcare and life sciences, what should we be carrying forward from the last 25 years of digital enablement in healthcare and life sciences?
Okay, I'll start by default. I think the thing to remember is that AI is just a tool. Foundationally, it's a tool to solve problems. And these are complicated problems with multiple stakeholders. This is core to what we do at BioDesign, to use a process to understand needs and stack those needs and the criteria for success across all the stakeholders right up front. I thought what Gretchen brought up before was absolutely excellent, which is that when you're solving a problem, you need to take all the stakeholders' concerns in mind. And if you do that up front, you're going to have a much likelihood of success. So I believe that AI is, I would hearken back to things like word processing. And, we all have word processing now. It's not a differentiator. The internet, selling dog food by the internet, is basically the same as selling it anywhere. It is an enabler of a new mechanism, but it is just a tool. And similarly, I think that it's going to be ubiquitous. It will be in everything. And we just have to use it and solve problems well. and take the stakeholders in mind. So that's as I look back at the technology innovations of the past, there's a lot of enthusiasm of new tools, and rightfully so. It's a very powerful tool, but fundamentally it's about the problems that we're trying to solve, focusing on those and making sure we're addressing the stakeholders in the right way, and ultimately we'll all have these tools and they'll be a part of everything we do.
I'll just add, I think the last 20 years we've implemented a lot of technologies in the clinical spaces, all for great reasons, but now the need and the proliferation of the interop, it becomes very complicated for the clinicians to understand how the different systems interplay. And I don't think we want them to be the troubleshooters, right? But it adds that complexity to them. Of course, it adds efficiencies, right? But I think the interop is what's new, right? That has really exploded in the last 5 years for good reason. So that's what I've seen. Big, heavy implementation, and now everything has to be integrated.
And I agree. I'll just use the case example of brain MRI scans, which is something that my colleagues and I look at all the time. And if you think back to 3 or 4 decades ago at the onset of clinical application of MRI, you would get these very grainy images. They would be on kind of slides you would put next to a light box so you could actually see them. Patients would have to take these large kind of microfiche type of files with them to doctor. Now that's part of our PACS system. It's all digitized. We can access it. We can transfer it, et cetera. But then there's still room for improvement even beyond that, because I'll just tell you, and I mentioned this yesterday when we were talking, whenever we pull up an MRI scan in the clinic, we always compare it to the prior one to look for changes in the growth of the tumor, et cetera. And it always takes us maybe 5 minutes just to kind of align the images and get the slices adjusted to account for the patient's head tilted, et cetera. And I'm sure that there are wonderful people in the audience here who are data scientists and AI experts who could write some kind of code just to kind of save us that 5 minutes per patient per visit to really help us and take that next step. And I think there's a lot of low-hanging fruit available, even with the advances that we have made in the technology, just to make the workflows a lot more efficient and effective, so that more time can be spent discussing the implications of these findings rather than just trying to set up the data in a presentable way, let's say, for the patient at the bedside.
Those are great points. I think as we think through the introduction of automation and predictive analysis in the patient care settings, a lot of focus, which I'm very encouraged to hear, is that it's not so much about the point solution, it's really about the problem identification. And so we have great perspective from different avenues of the industry. Could you guys talk a little bit about some principles or ways to go about engaging your stakeholders on identifying problems and not so much focusing on what solution to adopt and implement? Absolutely.
This is core biodesign. I would say if you're not aware of what biodesign is, come check out our website. We have a lot of resources. There's a biodesign guide that's online. We have a textbook, but this is what we teach, and it's exactly what you're getting onto, which is, how do you find a problem? Do you sit a bunch of people in a room and say, what are your problems? I will tell you that does not generally result in the right answer, because the folks that have the problems don't necessarily have the perspective of all the ways that could be implemented to solve their problems. In fact, many times the problems that they have, that they identify, are the ones that are right in front of their hands right at that moment, but there could be much more broader systemic problems that are actually impacting them, that they're just sort of accepted as the way things are. So the best way to actually get a grip on on what problems to solve is actually to observe, to go into the environment, to embed yourself, but not, this is interesting, because they say, well, physicians are in the environment, nurses are in the environment. They would, of course, know, but the fact is that they're there to do a job. They're taking care of patients, and they have to worry about that patient at that time, et cetera. But for you to go into that environment and to see what's happening and go, why are they doing this? Wow, that seems very inefficient. That's the type of thing that our fellows and our trainees find all the time. There's tons of opportunity to improve things like that. but believe it or not, folks that are embedded in the environment don't always see them. So my recommendation is go into the environment, find a relationship that allows you to see all the things that are going on, and also understand who all the stakeholders are so that you can appreciate what their requirements are. That's actually the way to solve these problems. With that requirement, we call it a need specification or need criteria, need statement. That's sort of our language for that. But once you've created that, that is the golden reference against which you can use to brainstorm and create and utilize tools like AI to solve.
Yeah, I'll just add, I think when I went into my role, I should have just had an email box, send your gripes here, you know? Because, you know, I think people reach out and say, this is broken, this is what, and you do need to be in the clinical space. Like we joke, who's the boots on the ground, right? And I think health systems that resource that boots on the ground do quicker iterations in innovation, because you do need an agnostic person to step in and say, okay, I realize what you said, but let's break that down a little bit, right? I don't think they know there's a problem, but they can't articulate exactly what system they're having a problem with, right? And that's the beauty of that agnostic evaluator, to really step back, you know, be quiet and just watch and listen. And it, you know, not every IT team is on site, right? And I think how you marry up with teams that have the boots on the ground and then the people who maybe are remote, you know, that's a real strategy that health systems are talking about.
I definitely agree with the concepts of, you know, embedding staff, you know, and kind of outsiders into the clinic to get a really new perspective, as well as this, you know, idea of the gripe box. We always, you know, commiserate with each other, like on the daily basis, like just kind of, you know, the inefficiencies of the electronic medical record system, or whatever it may be. I think one of the most extreme examples, it's not that I would recommend this to look for problems, but, you know, we have a monthly morbidity and mortality conference in our department where we report in a very open environment, you know, very frankly, errors that occur, whether it's medical errors, et cetera. And it gives us an opportunity to really understand kind of at the, we call it like the Swiss cheese model that lead to medical errors that are so multi-layered, right? It's the institutional policies and frameworks and practices that are in place. Then you have the departmental ones, you have the clinic team and how that's organized, maybe a physician, an advanced practice provider, a nurse, a pharmacist, et cetera, and then the individual provider. And at some point along the way, or at maybe multiple points along the way, something was missed or an error was made and then propagated through those, you know, multiple layers of the holes in the Swiss cheese to lead to the direct error, which may or may not cause patient harm, but nonetheless should be reported, you know, to the patient. And I think something that I've learned a lot through these types of morbidity and mortality conferences is getting through all of this to understand what the issues were that led to the error, but then in so doing, you're almost kind of doing a root cause analysis that can then help generate the ideas for solutions at the various levels to reduce that possibility from happening again to future patients.
Yeah, and I'll just add, you know, we've had our vendors. We've had Philips in quite a bit, and that's part of the contractual arrangement we have, is that we have clinical evaluation hours, and other systems have it too. And I don't think we always leverage that resource, and it's amazing what they tell me the staff are doing and not following policy. And again, it's, you know, I think you're right. Like, I put myself in the environment and I can see, okay, maybe that's why they did it, but there's a policy for safety reasons, and that an agnostic person can also be your vendor resources too.
Yeah, absolutely. I think, you know, even from experience, right, the solicitation of engagement from all of the stakeholders is so key, even at the success of deploying reality-making technologies. And I think, especially for our audiences that are leading startups or have ideas and are in the ideation phase or whatever phase of their company products they are in, this is a really important perspective to carry away, which is the engagement of your stakeholders, the understanding of your environment, and the overall beauty of the practice of observation. It's a very important one. I think that kind of leads us into maybe the next topic, which is going to be really when we think about the patient room or patient experience of the future, both from a product standpoint, right? Interestingly enough, in our world, we've seen the deployment of many point and spot solutions from technology development partners like Philips and other companies. We talked a little bit about interoperability of those devices and how important the data communication between disparate systems to represent one fabric. What are our thoughts about the future of what a patient room could look like from a technology standpoint, and some of the benefits that highlight our clinical stakeholders and what they'd like to see?
I think it's going to look very similar to the way it does today. However, there will be a lot more intelligence about, I'd say artificial intelligence, about what is being monitored and how it's being communicated. So the opportunity to, instead of, someone having to come in, check something, read something, then go find the appropriate person in the hospital who can then respond, and all the delays and all that kind of stuff. The opportunity for AI to shortcut those workflows, to make the correlation of information more valuable, to highlight tests and readings in the room from patients, it's going to be incredibly impactful. It is absolutely going to happen. And I think that I know there's a lot of concerns about, sort of skipping over caregivers. That's not the idea. The idea is to really facilitate, to make all of the caregivers, the humans in the environment, their lives easier, and to allow them to make them more productive and honestly have a better quality of life in the way that they deliver the care for their patients. I think there's a lot of fear about AI replacing people. I don't believe that's going to happen. Think about how burdened our caregivers are who are in the environment today, and all of the laborious and very inefficient things that they have to do to get to the part that brought them into the careers in the first place, which was about touching patients and helping them. So I believe that these tools are going to allow humans to do what humans do best, which is really to provide care and a human connection to patients that really need it, and to try to eliminate all of those things that are laborious, information and time intensive, and allow those things to more shortcut, workflows to allow for better care overall. So I think, instead of there being fear of replacement and, checking on performance, that's not the idea. I think that the better utilization is actually to use it to elevate care and to give humans more time to do the part that only humans can do. And that's really the value of this technology.
Yeah, I remember back from a past rollout, where Rounding and I went into a patient's room, and of course, you do an IT rollout, and the first patient you go talk to is an engineer. And he said, well, I didn't come here for the tech. And he's, sitting in Stanford Hospital. I came for Stanford Nursing and for my surgeon's hands. Now, technology enables all that, but that was really striking that an engineer articulated why he came to where he did. We've done a ton of pilots in the clinical spaces, and I'll give one example. We thought patients would want to control their environment. If we gave them an iPad, they could do that. Well, what we realized is a surgical patient can't and won't control their room on an iPad. They're not ready to do that. The one thing they want is their nurse bell and their pain medicine bell, right? And that's their focus, rightfully so. You devolve after, a critical surgery to only being able to manage that. So I think that was fundamentally wrong, that in the early stages after surgery, you wanted to have that responsibility. Now, if I'm an oncology patient or a bone marrow transplant patient and I'm in that room for a month, yeah. So I think we need to think about what are the different patient phenotypes and what they want to control or experience in their room, because I think it's going to be very different whether you're an ICU or if you're an oncology patient or a surgical patient. I think we have a lot of testing. And I worry sometime as more moves to ambulatory that the patients in the hospital will be the sickest of the sick. And so how do we keep trying to make the environment as quiet as possible, as therapeutic, but really enabling the care by the providers and the clinicians that they need?
I definitely agree. I think the customization is key, particularly in the outpatient setting, where each clinic at each institution has its own way of looking at an update of patients. So I'll give you an example of pre-charting before a clinic day where you're trying to figure out what happened since the last time I saw the patient until the present time. And we all have a kind of systematic or idiosyncratic way of doing it depending on, which specialty you might be in. And so, just thinking about, being able to go through the EMR and have a console available to you that says, since my last visit, what are the trends in the functional status score or this lab or that, or whatever the key diagnostics may be. Taking the information that's already available to us, but more rapidly synthesizing it, distilling it, and displaying it for us to not only help the provider, but then, of course, the patient in terms of displaying in the clinic. And then, of course, as was discussed yesterday as well, how do we then allow us to spend more kind of face-to-face time with the patient, not with our backs facing them as we're typing in all the updates they're giving us, but have even our post-clinic notes prepped for us that we can then edit and fine-tune, so we can then make sure that our documentation is updated, but it's also communicating key details for other providers between the current visit and the next one. So again, leveraging the information that's already there, but in a way that customizes it to each department, or maybe even each individual in each department, just to make their workflow a lot better, and getting to the point about, as you were mentioning, being able to take care of the patients. So.
Yeah, that's wonderful. I really am intrigued by the sort of thought and guiding principle of what is the goal for the future of technologically enabled healthcare and digital transformed healthcare now through automation, and the whole mission, of restoring the time between human interaction by distilling or advancing development of technology's presence in our workflows is really fundamental to both, I think, the work that's happening today at the patient bedside and also the work that's happening on the back end of the industry where ideation and thought process is being put into what the products of the future look like. And so maybe drilling just a bit down into that, and Josh, if you could start us off, in your mind, what are some things that we could expect to see from the products of the near future that could highlight that principle, which is how does this technology, as we deploy it, work in the ecosystem or fabric of the physical setting and the care of the patient, but doesn't impede on the interaction between the clinician and the patient?
Yeah, I think we're already seeing some of these tools already that you may not even realize are there. And so that's a good analog for what's also in the near future. For example, one of our students created a company called Viz AI. What does Viz do? They have installed an AI algorithm at the level of the scanner that when someone comes in and has a brain scan, it takes a look and see if someone has a stroke. And instead of that scan being complete, waiting for the radiologist to read it, radiologist says, oh my gosh, we got to go, and then finding the right person, the interventional radiologist is notified right away on their phone with an image saying suspected, stroke. They look at it and go, yes, I will be right in. Cutting through all that workflow, right? So I believe that these and no one's job is being eliminated, by the way. There's still going to be a radiology read. There's still, all these things are still going to happen. But to be able to enable better care and better outcomes in that way, I think that's what that's the type of thing I think we're going to see a lot more of, is this sort of workflow-related data acquisition and suggestion of a diagnosis, which allows a physician or a caregiver to, sort of actually render the final diagnosis and take action, but sort of enables, sort of jumps through the usual steps that would normally be in a hospital. So I think that's sort of analogous to the types of things that I think are going to be the most impactful in the near term.
Yeah, excellent. And I think just kind of rounding out the perspective that we have here, Dr. Patel, from your standpoint and involvement in research, as we know today, a lot of what is happening at the forefront of healthcare, especially at the bedside, with all of the integration and interoperability that we have, that data is paramount to the research that many organizations, academic medical institutions have. In your perspective, can you give some examples or thought to share around how automation or predictive analysis, AI, can assist with the current practices of research and how it could potentially reshape that for the future?
Absolutely. I think one thing to keep in mind, obviously, whether we're talking about basic research or translational research or clinical research, is that what we see in the published literature is literally the tip of the iceberg, right? It's maybe like 10% of what's ever been done. And, there's that joke about let's publish in the Journal of Negative Results, which would be, just, tons of volumes of information, which I think is still critical, right? Because that is still knowledge to know that this was tried, this intervention in this cell line, it didn't work under these conditions, so that they're not replicated again, or others don't invest their time, energy, et cetera, in that. So if we're going to use AI to learn from the published literature, which is again biased towards positive results, then we're not necessarily encompassing the entirety of what has been tried before. So that's one thing we just have to know from the outset. Obviously, it's really hard to be able to account for or publish, so-called negative results, for example. But as it pertains to what we have in the system, there's just so much information and data that's available at different levels, whether it's in text format, in clinic notes or diagnostic notes, in imaging format, whether it's ultrasound, MRI, CT, et cetera, and then the squiggly lines from EKGs or EEGs, et cetera. And how do we use the best analysis for each of those types of data to combine them across different modalities to make more sense in a maybe temporal manner to maybe predict that something is about to happen. There's about to be a seizure in a patient whose brain tumor seems to be growing on the MRI scan. They had an EEG 6 months ago that showed some irritability in the brain, and this can predict for us that, okay, we need to be more mindful of monitoring them, whether it's another scan or just a check-in, or whatever it may be. But I think the lowest hanging fruit is for patients that are, again, I'm coming from the oncology world, who are on chemotherapy, which we know oftentimes leads to low blood counts because the bone marrow is being suppressed. And so in our clinic, when we have patients on chemotherapy, we still have this analog version of a calendar where we check on a weekly basis. Okay, make sure to check the complete blood count result on a weekly basis, and let's look at the platelets and the neutrophils, et cetera. And so, having systems in place that could alert not only the team, but the patient directly to say, oh, your platelets have dropped too much. Are you having any symptoms of bleeding? Or if so, go to the ER. And just having those very automated safety measures in place based on the data that's already existing could be something that can, I think, facilitate a more safe environment for the patients, and then also for the clinic teams, of course, not to become less vigilant, but then to be more quickly apprised of what's going on, to then take that human interaction to follow up with a phone call or a message or whatever it may be.
Yeah, absolutely. I mean, it's quite staggering to think about the amount of data that is generated in the here and now with all of the technology that's been deployed in life science and healthcare, and how much it's being leveraged and the potential of using more of it in a meaningful way. Lastly, I also wanted to highlight the topic more specifically around bedside monitoring, and we'll start with Gretchen, specifically around monitoring, which has taken leaps and bounds in advancement over the last 20 years. What specifically would we like to see occur as far as the evolution of bedside monitoring enabled by AI?
Well, I think reimagining what it looks like or feels like to be monitored. right? I think that's the first thing, whether we have to be tethered to a machine or not, or you can do it ambiently, or there's other things in the room, and can we use proxies? Like, do we always have to have somebody attached to a vital sign machine? And we know that it limits mobility, which is also not good for patients. I do think that we're gonna all explore home as the next platform. And I think it's a real opportunity to think about how we do that monitoring in the home. And so I think there will be a bedside in the home, right? Both for our older population, it's really always better to do what you can in the home, for their oncology population to keep them at their lowest counts, you know, out of the clinical setting. So I hope that that will be reimagined in how we can not have the workflow be so centric on the hospital, the clinic setting, more workflow around the patient and what are the options that we can give them.
Anything to add to that from the panel?
I think you're right, Gretchen. I think that when we think about the limitations and the cost of healthcare, especially at home, and especially for, you know, end of life, I mean, it's that part of our system is so broken. The opportunity to use tools like this to improve access, improve care is just tremendous. But we have to be able to embrace change. And, you know, if I were to say, like, my vision of the future of healthcare, it's going to be a little bit like shopping in retail, which is, I believe, I don't know if it's 10 years away, it may be longer, but things are moving pretty quick, so maybe it'll be sooner than I think. But I think a lot of the healthcare that we get every day and at home is going to be directly directed by an intelligent, you know, software platform that's going to be interacting with, and we're going to prefer it, by the way, because just like Amazon, it's at our fingertips, it's available whenever we want it, and it's available round the clock. Humans can't do that, it's too expensive, but a machine, digital, can do that. And so I think that a lot of the everyday primary care needs are going to be directly dealt with on a machine basis without doctors in between and without nurses in between, because they'll be good enough, but we'll always have the option, I believe, in this virtual system that I'm imagining in the future, to go to the next level. You want to talk to a human? Great. Telemedicine right there. Push it. Or you might have to wait a little bit, finally get to talk to a human, but you will be able to have access to a human. And maybe it'll first be a nurse, and then maybe it would be an elevation to a physician. And maybe even you might need to go into an office, and that would be the next level, actually going into an office. But that would be pretty rare. Just like it's pretty rare to go to, you know, shop in a store today. I mean, that's wasn't like that a long time, not that long ago. I think that's going to be the future. And of course, there'll be things that only, you know, humans can do, in-person surgeries maybe, at least for now, and all sorts of interventions like that. You know, certain types of diagnostic procedures have to be done in person. But I think this is sort of the scaled system that we're going to. It's sort of the only way we're going to get healthcare costs in line and improve access for people. It's just sort of the future. It's going to happen. And we just sort of figure out how we can adopt to it. And I believe that the doctors of the future, the nurses of the future, are going to be happier because there will be less of the mundane, everyday workload that does not really require anything but a formulaic, guideline-based algorithm that humans are doing today, but machines can do much better. And as a parallel, you know, to this system that I'm imagining, it would need to be monitored. You know, we need to have the data and interoperability problems solved so that we can keep track of outcomes and make sure that the, you know, machine's not going rogue and it's not starting to do things that are wrong. I'm definitely a believer that in terms of a regulatory framework, that the existing regulatory frameworks do not work for this, that it's a little bit more like regulating a practicing entity like a human, in terms of they graduate and then you keep track of them, except in this case, we have since it's a digital tool, we can keep track of their performance and the outcomes with every interaction and make sure that they're staying on track and that the patients are doing well. And so that power, I think, will enable it to expand, and then we need a backup system when it does go rogue, so that we can make sure that we go back to the last version that was performing very quickly, so that we don't wind up with a runaway train. And those are the types of things we need to think about. But I definitely think that's the future of where this whole endeavor is going.
I think if we want to really realize the full potential of AI to help us with real-time monitoring, immediacy of getting to a diagnosis, for example, we'll really need the colleagues in technology to improve the ability through biodesign and other methods to allow for this. So I'll just give an example of when we see patients with a stroke, we want to figure out why did they have a stroke? What are their risk factors for having a stroke, so that we can modify those to reduce their risk of a second stroke. And one of the major risk factors would be something called atrial fibrillation, which is an irregular rhythm of the heart. So in the inpatient setting, patients get put on something called telemetry, where their heart rate and rhythm is monitored. If they ever have a period of atrial fibrillation, there'll be a physical strip that's printed. Someone from the central monitoring station in the hospital calls the nurse and said there was a period of this. The strip is placed in the patient's chart. When the clinic team comes by the next morning, they may or may not even review the chart, or may not even know that the atrial fibrillation episode happened. And so it's a very slow process. In the outpatient setting, patients can get something called a loop recorder, where they get a 30-day monitoring of their heart rate and rhythm. But unfortunately for that as well, that's not real time. So what happens is that the data are sent after the loop recording is done for 30 days. That device is sent to the manufacturer for them to then decode the information, and then after the fact say, yes, during this period you had